Now we're cooking. All right, so we'll watch that one more time just to.
Oh.
So it starts off, you have 1 cup each, the taller cup wins. Start stacking the cups up a little bit. Taller stack wins. Take a couple cups off. Now the stacks are even. So our goal today is to try to figure out how many cups are in both of those stacks to make them have even number of stacks. Because remember, you're adding 1 cup to each side every time. So they have the same number of cups in both stacks, but now they're even. So we're trying to figure out how many cups are in each of these stacks. What is that nice little number of cups? That will give you 2 even stacks. So at the top of your paper, it has 2 low, official guess, and 2 high. So I want you to make a guess that is low that you think will not be true at all for a number of numbers. A guess that's too high, and a guess that's like your actual guess that you think the number is. Actually, let's put that away, please. Okay. Thank you. So how many cups do you think are in those stacks to make them even? I believe Mrs. Rubright's done a couple of these last year before, so you might be familiar with the methods. Once you figure out your guesses, try to think of some things. What are some things you notice? What are some things you wonder about the situation? And see if you can draw a sketch of the 2 cups to see if that would help you figure out your answer or help you visualize the representation of the problem. Any thoughts, Bradley? So I'll give you just a little bit longer to write down some things that you wonder, things that you notice, and to draw your sketches of the situation. I don't expect your sketches to be artistic very much. I'm not an artist, so I couldn't do anything very good. What are you thinking in this situation? What was something like that. Or something If you can think of some things that you would need to know in order to solve the situation, you could write that down below as well. So what are some things you might need to know in order to solve the situation? What are some numbers that would be helpful? Oh, is that the answer? So little.
Okay.
Maybe I'm colorblind. Some people.
So what are some things that you might need to know in order to solve this situation? What are some things that help us figure out the answer? Okay. So what are some things that was that what this is?
Yeah. The rings were casual. So,
Like from the white one.
the blue, yeah, styrofoam ones, they're so the blue, they go further. But on the styrofoam, because the rims are on, so it doesn't go as quickly. We have more air space, making it big.
So the rim. Any ideas of things you might need to know? That's important. What are some things you might need to know by Okay. All right. So, what are some things that are important to know that can help us solve this question on how many cups we might need? Zoe?
The little cups have a bigger thing that they stack on.
So the styrofoam cups, they have like a thicker bottom to it, or like a rim to it. Okay. So what about that rim would you want to know? What specifically?
How big it is compared to
So how big are the rims? Okay, good. What other information would be helpful for us on this problem?
How thick the difference?
What was that?
How thick the cup is.
How thick the cup is? Okay. Any other thoughts? What was that?
Height.
How tall the cups are, or what is their height? Okay. Good. Any other questions people thought would be helpful to help them solve? What was that? Oh, okay, sorry. I thought you said it. All right, so I have some information on two of these situations. So in this picture, we have our styrofoam cup. We have that lip, or that rim of the styrofoam cup is 1.3 centimeters. I'm sorry if you can't really see that very far from the back. There's 1.3 centimeters on the lip of our styrofoam cup. We have the total height of that cup is 9.2 centimeters. And then for our blue solo cups, that little lip that it's sitting on top of is only 0.8 centimeters. And then the total height of your cup is 12.1 centimeters. So this is our information we have to start with. So using this information, your goal is working together in your groups how can we use this information to help you solve for those missing, or how to solve for how many cups will get you equal height of your stacks. So how many cups are in those stacks to make it equal? Once again, the stacks have the same number of cups in each of them. So if you want, actually, do you have a question?
Does it have to be exactly equal, or can that be off by?
It won't be exactly equal. So you're going to get something that you'll probably find something that's either really close, or you might find a number that's like close to a whole number of a cup. So try to estimate as close as you can, or not estimate, but your number you might have to round just a little bit to get it close. Let's see. Landon and Dylan, I'll have you work together just so you're not by yourself. All right, so work together with your groups. Start thinking of what are some ways that you can solve the situation. What are some ways that you can figure out how to determine how many cups are in each stack? If you need space to do the work, if you flip over that first page, on the back is space to do math and work. So what are some things to think about?
So every time you add on,
Okay. So how would you increase what we do? Well, like, what are you using a table, or what are you going to do with that? Okay. That's a good thought. Wait, let's try that. You have to build this out. You think a table will help you, then you can use the table. What are our thoughts? So every time you put a cup on, explain how it's changing. How are the steps changing? Right, so you're adding on that little lip each time. Because, like, you know, you try looking for. So what would be the easiest way to probably track that? How would you say that? Would you just table? Or you can make a table. That's an option. So see where to start with, or figure out the number to start at. See if you can keep adding on points just going to change by. Okay, that's an option. What are we thinking? Okay. So how are you gonna keep track of that? Just write it down. Are you already step ahead? What are our thoughts? No, what do you want? Okay. And then they still have that height on there as well. How can you represent that, or how can you look at it? Well, I like the multiplication of space. That's good. It's like this
Yeah.
So how does that table work out? So for one cup, I'll call second.
What means that?
So at one cup, just a cup.
Oh.
Yeah. If you need a calculator to do your work, I have a couple at my desk, or you can grab one from a supervisor room if you'd like one of y'all.
Ashley, could you have one of those?
Alright, so
That's so nice.
Thank you.
when you kind of mess up, how is that changing? What's changing? How is that changing? When the second cup increase the whole height by the whole 9.2 with the 12.1, what's changing? Another thing for how much does it change? Well, you have that would change the whole height of the cup, right? The three, it's not gonna stack the whole height of the cup. How much is it? So it's only gonna be changing by the 1.3. For the blue cup, 28, for the it's called how are we doing? How are But is that the only height you're comparing to the equivalent? Okay, so how much is the height increasing by the time you think about it? What's actually? Okay, so at one cup, or one stack, how tall are these three stacks? Alright, now you add a cup to each of those stacks. How much is one side? You just add the cup for your 2.8. Just get that principle here. Find out what Alright, so what's your you can probably get a little bit closer then. Yeah, it's a little bit more. Well, if you're out of the higher than that, get a little closer. You're close. So you can have 4 bases. Wow. Did you have the height for 4 bases and then the high for the height of the entire cup? Leave that base at once. Do you really have 5? But you can get close. Everyone's thinking.
Okay, I think that's.
Basically, the height of the
Okay,
base.
so
We're only so far off.
rather than math, so you had another thing. We found that's once and yeah, lots of stuff. I mean, everybody was like, okay.
You know. You might take that.
I didn't know. I want to wash your hands.
Right, so let's focus on this. So at one height, or one cup each, what are your heights?
9.2. But one's 1.3. 3.0. That's an 8.9. And 18 points. Or 12.1.
So what are they? You have 12.1 and then 9.2. That's just one single cup, right? You add a cup on it. How do we take it? Alright, so what are their heights? Yeah. That's one. That's your right cup. What's that your other right?
12.9.
Okay. And you keep adding on top to it. What do you find? Okay. Pretty close. Pretty close. You increase the step by
I know this is going to be less than that. That's all over again. That's all over again.
do you know what to do?
No. Oh, yeah.
When you find it.
Oh, good. The height.
Now, I know who they use the total height of it. You did 4. I'm that's 4 base. That's 1, 2, 3, 4, right? And then you add on.
Okay, so you are at 12.8 and plus 3. So, oh, shit. I'm an 18. You got it.
So how are you increasing your size of your cup?
Mom just said 30 years.
We have room? Anyway, that's
Oh, okay. Yeah, it goes. Okay.
Shoot, I didn't put all my numbers on the wrong number. Yeah, I put on 1 plus 43 and I should go. Oh, so I've done that. Open my first fight to add on to me. Oh, I messed up. That's just it. Put on the wrong side. Go on forever.
But it's point. Just a single one, it's going to be 9. How many times have I analyzed?
Okay, I don't want to have one, it's like
So you think of a question. All right, so let's talk about this. So, what did we find for our? What did we find for our answer? What did we find for our thoughts? Do we agree with 7 cups?
Yes, we do.
How do you come up with that?
Adding the side of the cup, adding the base of the cup, yeah.
So you started with, what did you start with? What was the height of 1 cup?
9.2. And then add 1.5.
9.2 and 12.1. So you add onto those cups, you add a 1.3 each time, and then you add a 0.8 each time. So you start with 1 cup, then you get a second cup, and you keep going, and you said they met at 7 cups. What were your heights at 7 cups?
It was 17 and 16.9.
17 and 16.9. So these are only off by 0.1 of a centimeter. So let's see if you're right. Let's see if we got the right answer on this.
I got that.
So 7 cups was the correct answer. Or at least very close for the correct answer.
17.
So let's talk about a couple of ways that we can go about finding this. Okay, this is the important part, not necessarily the cup. So, on thinking about these 2 cups, we have a blue stack and we have a white stack. So I believe the majority of you, or I believe most of the groups, decided to start with a single cup and then they just increase by 1 cup each time, or the height of 1 cup each time, or the base of 1 cup, until they saw they were close. So what was the height of our first cup, of our blue cup? 12.1, and 1 cup for our 9.2. So we saw that every time we added a cup onto it, we were just increasing by the base rather than the entire height of that cup. So when we added a blue cup on, we increased by 0.8 and we got 12.9. When we added a white cup on, sorry, we're not at 2, We added 1.3 and we ended up at 10.5. We kept increasing these heights all the way until we got to 7 cups, which if you feel so obliged, you can fill out the rest of your table. I ended up with 17.1. I probably did some wrong math there or something. I know a lot of you said 17, so I might be mistaken on that on my paper. Okay, we'll say it's 17.
Not 17.1 and 16.9.
Yeah, I probably messed up on that.
Yeah, boy.
So you can keep increasing by that same amount, and they get pretty close. So this is one way to solve these problems. Trying to figure out when these two things are equal. One way is to create these equations and keep adding on to them until they meet or get really close.
It's pretty easy.
But the thing is, what if it didn't take all the way to like 53 cups before they were equal?
And then we would have done 53 times.
That would have taken a while though. That probably would have taken the whole period, right?
You could have done, you can hack the internet and search, hey, how many blue cups? 9 times, like cups.
Another way of going about this is thinking, what are the equations that represent these situations? Anytime we create a table, we can figure out what the equation is for that table. So each of these are increasing by a constant rate. So constant rate, anytime we have a constant rate, a constant increase, we have that linear function, that linear equation, that slope that keeps coming down. So we know it's going to be in the form y equals mx plus b. But we have to think, what is going to be my slope for my blue cup situation? How much is it increasing by? What is that constant rate that keeps coming back in this situation? 0.8. So I know for my blue cups, it's going to be y equals 0.8x plus some b. Now what is the b going to be? What's my y-intercept for that situation? What was that? Close. So 12.1, if we think about it, 12.1 is that 1 cup. But our y-intercept always occurs when our x equals 0 and we're hitting that y-axis. So we actually have to go back 1 farther to figure out what's that number that's always being added on, or that number that's being added on in the end. So we were actually to decrease 1 farther to say we had 0 cups or 0 bases, because this really represents how many bases you have. If we were to think back, we would subtract 0.8, we would be at 11.3. So if we want to figure out how many, or the height of any number of cups for the blue stack, we just plug however many cups in to x, and the height would be our y. We take that number of cups, multiply it by that base, and add on the 11.3, and that's the height of our stack. We can do the same thing for our white stack. We saw that it was increasing by 1.3 every time. If we think back to what that y-intercept is, we know 9.2 is the first value, but we need that 0th value. We need that initial starting value even before 1. So we'd have to go back a 1.3, which that should give us a 7.9. So these are our two equations. Once again, we plug in some number of cups, it would give you some number or some answer in the end. Now the reason we have these equations is we said it can be very hard if we had to go for like 53 cups and keep making this huge long table. So the reason these equations can be helpful, we're looking for when the heights of these cups are equal to each other, correct?
Sure.
What variable on here represents the height of your cups, or the height of your equations? Travis?
It's the B.
So the b was your y-intercept. That was your initial value. Or, sorry, not the height of your cup, the height of your stack. I'm sorry, I should have said that better. So which value on here represents the height of your stack? It's going to be your y of each of those equations. So you plug in some number of cups, and it gives you the height of your stack and your y. So if we want those heights to be equal, we need those y's to be equal to each other. So we need this whole equation to equal this whole equation. 0.8x plus 11.3 to equal 1.3x plus 7.9. So we need those whole equations to be equal to each other. Could we solve this?
Why not? Yeah.
How would you go about solving it?
One.
Yeah. Math.
Alright, so you want to get this constant over? Did you say 11.3 or 1.3? So we give 0.8x on one side, and that's equal to 1.3x. 7.9 minus 11.3 should give us. I don't have it. Someone have that off the top of their head. It should be. Yeah, I do that. That's in the middle. What did you get? 5.6. Negative 5.6. Let me check that one more time. 11.3. Thank you. Sorry. Negative 3.5. All right. So in order to solve, we need to get the x's by themselves. So we need to get those x's back to the other side. So I'm going to subtract 1.3x from both sides. So 0.8x minus 1.3x, that should give us 0.5 or negative 0.5x, which equals negative 0.34. Last step, divide by negative 0.5. And so our x equals negative 3.4 divided by negative 0.5. And that gives us 6.8. So that's really close to 7, which is what we thought. But our 7 answer was a little off, so we know it wasn't exactly 7, but it was really close to 7. 6.8 is really close to 7. Obviously, we can't have 6.8 of a cup, though. So 7 would be our correct answer for our cup situation. So here is why this is important. So we call these system of equations. So when you have two equations, or three equations, when you have multiple equations, and you are trying to see when those equations are equal to each other, we call these systems of equations. And that's what we're going to learn about in this next unit, basically through December, is we're going to learn how can we solve these system of equations. So there's a couple ways you can do it. We saw we can make a graph and see when the graphs are equal. We saw we could use equations. Another situation, or sorry, not a graph, a table. Another situation is you can make a graph, and you can see when they touch each other. So these are all different ways of solving systems of equations. You may have been introduced to this just a little bit last year in 8th grade math. I believe Mrs. Rubright did a small portion. But our answer for systems of equation, the solution that we have, is always going to be that whole point. It's not just going to be a single value. So in the situation we have, we are just looking for x. We are just looking for what is the number of cups. But for our solution of systems of equations that we'll use in the future, we're going to use these whole values, or the whole point. It's going to be a whole coordinate point, an x and a y. So you're going to have an independent variable and a dependent variable of the situation. So you're going to have both. In our case, our independent variable, that represented our cups we had in the situation, and the dependent variable represented the height. The height wasn't really as important, but the independent variable was what we were looking for. But when we continue on in the future, we're going to need to know both of these values. So we don't really have much time to continue on today farther from this, but we will continue talking about system of equations. We'll continue using them. We have a couple of different methods of solving them. We can solve with graphing, we can solve with elimination, and we can solve with substitution, are the three methods we use. So we'll continue to use these and we'll continue to learn these throughout December, and then you'll take an assessment over these in the, I think it's like 18th or 17th, one of those days. And so that is our goal for the future. Good job today. Thank you.
Thank you.
I am not about to-
No.